Hey there, gang. In this next video, we're going to be discussing Venn diagrams. Now, chances are you've probably seen Venn diagrams before. They're very useful visual representations not only for math class, but to compare similarities and differences in concepts in any study. So you've probably seen them used in science or maybe English before, but this video is going to really set up the basic structure of a Venn diagram and relate it to what we've been talking about with our conditional statements. So as I said, Venn diagrams are a visual way of displaying the relationships between sets, and there are three main types of Venn diagrams. There are what we call the always Venn diagrams, the sometimes Venn diagrams, and the never Venn diagrams. So an always Venn diagram looks like the one you see on the far left, and let's just say we have two separate statements, P and Q, for our conditional statements. This diagram means that all elements of P are elements of Q, or what we're used to seeing, P implies Q. This means that if you are an element of P, then you're automatically an element of Q. You've seen a Venn diagram like this type before when we talked about the different number families in Algebra 1. If you remember, let's say I have the natural numbers. The natural numbers are automatically a part of the whole numbers and the integers, and so the entire circle of natural numbers are inside those circles of whole numbers and integers. So that's an example of an always Venn diagram. The type you're probably most used to seeing is the one here in the middle, and this is a sometimes Venn diagram, and you'll notice the two separate circles P and Q have some overlap, but not an entire overlap, and so the representation for this using our notation is the outside of the Venn diagram. Okay, so this part here would be P or Q. That inside part, where those two circles overlap, is P and Q. So that means that some elements of P are elements of Q. Finally, we have the never situation for Venn diagrams, and this is two separate circles where there is no overlap whatsoever. And that just means that if you're a part of P, you're never a part of Q, and vice versa. Going back to the number families, this would be a good example for rational and irrational numbers. If you are a rational number, you are not irrational, and vice versa. You can't be rational and irrational at the same time. They're opposites of each other, so that's an example of a never Venn diagram situation. So if that didn't make sense, this will hopefully make a little bit more sense as we go through some more examples here. In examples 1 through 6, we're going to be given a statement, and we're simply going to draw a Venn diagram to represent that particular statement. So number 1 says that some students who take chorus also take band. The key word here is some. If you see that phrase, chances are you're going to have a diagram like you see in the middle. So I'm going to draw an overlapping Venn diagram like this. One of the circles is going to represent the students who take chorus, and then the other circle will represent the students who take band. So notice that if you fall in this region here, you're a student who only takes chorus. If you fall in this region here, you're a student who only takes band. But if you fall in the middle where that overlap is, you take both chorus and band. All right, number 2. No perfect squares are prime numbers. So keyword here is no. This is going to be a Venn diagram where our two circles are completely separated from each other. One circle is going to be the perfect squares. And then the other circle will be the prime numbers. And if you think about that for a moment, to be a perfect square, there has to be some other number that you can multiply by itself to get your perfect square, and that defeats the definition of prime. Okay, so no perfect square is going to have only factors of 1 in itself, so therefore it can never be a prime number. All right, number 3, numbers divisible by 6 are always divisible by 3. Keyword here is always. So we're going to draw our Venn diagram to be one larger circle, and inside that a smaller circle. So the smaller circle is going to be the first part of that statement, the numbers divisible by 6. And if you're divisible by 6, you're automatically divisible by 3. So that's the larger circle. So any number inside the smaller circle is divisible by both 6 and 3. Any number that's only inside this circle here will not be divisible by 6, but will be divisible by 3. But every number divisible by 6 is always divisible by 3. That's why we draw it this way. Okay, number 4, every natural number is a whole number. Keyword there is every. This is kind of what I was talking about at the top there. You've seen back in Algebra 1 a diagram similar to this before. So the natural numbers are automatically a part of the whole numbers. All right, number 5, some vertical angles are complementary. Keyword is some. So I'm going to draw the diagrams again that you're probably most used to seeing. Okay, so vertical angles will be one part of the Venn diagram, and then complementary angles will be the other part. And you know from our discussion of angles that vertical angles must be congruent to each other. Complementary angles must add to 90 degrees. There is a situation where vertical angles can be complementary, and that's if they're both 45-degree angles. So that would be that section in the middle there where the overlap is. All right, finally, we have irrational numbers are never rational numbers. Again, I talked about this up above. This is an example of two what we would call mutually exclusive sets, meaning they can't ever be a part of each other. So if you're irrational, you are not rational, and vice versa. All right, so now if you go to the back side, I've given you some Venn diagrams along with some statements, and we're going to shade the part of the diagram that represents the statement. So number 7 asks us to shade just anything that would be included in Q, and that's going to be everything in the right circle. So I'm going to shade everything in that Q circle. That would be everything that's a part of Q. Number 8 asks us to shade everything that's a part of P and Q. P and Q is the overlap region of our Venn diagram, so that's going to be this part right here. If you're in that overlap region, you're inside both P and Q at the same time. Number 9 asks us to shade P or Q. P or Q means we're just going to shade all of the parts of P in addition to all of the parts of Q, because you can be in either or. So watch what happens when I do this. I'm shading all of my first circle, P, and then I'm shading all of my second circle, Q, and my entire Venn diagram is now shaded when I have P or Q and this type of Venn diagram. You shade both the overlap and the individual circles themselves. Finally, number 10 asks us to shade P and not Q. Think about what that means for a second. Okay, we want to first of all shade everything that's included in P and everything that's not a part of Q. So I can't shade any part of Q. I can only shade the parts of P that are not a part of Q. So that's going to be shading everything inside P with the exception of the overlap. Because if I shade the overlap, then I have shaded Q, and I'm supposed to shade everything that's not Q. So that's what that would look like. All right, in this last set of examples, we're going to describe the Venn diagrams given using a conditional or a compound statement. So kind of the opposite of what we did on the front side of the notes. So in number 7, you'll see that we have an always Venn diagram. Inside we have angles that measure 60 degrees, and the outer circle are acute angles. So this is saying that angles that measure 60 degrees are always acute angles. If we want to turn that into a conditional statement, we need our if and thens. So we can say if an angle measures 60 degrees, then it is an acute angle. Remember, an always diagram, if this is P and this is Q, means that P implies Q, so that's where I'm getting that statement from. If an angle measures 60 degrees, then it is an acute angle. All right, number 12, I have shading involved, so this is going to be a compound statement. You want to think about what this shaded region represents. If volleyball is P, and piano lessons are Q, then this is going to represent P and Q. Okay, so I'm going to write a compound statement with the word and. So I could say some people, because this is a sum Venn diagram, play volleyball and take piano lessons. All right, number 13, we have another sum Venn diagram. This time we have art class on one side and freshmen are the other. The only part that is shaded is the freshman part, but not including the overlap region. So if this were P here and Q here, this would be not P, because we've not shaded anything inside P and Q. So this would represent the students who are freshmen and do not take art class. All right, finally for number 14, we have multiples of 7 completely shaded, even numbers completely shaded. So if this is P and this is Q, this represents P or Q. So a good statement for this would be numbers that are multiples of 7 or even numbers. All right, if you had any questions over this video, make sure those are written down for the next time. Until then, have a nice day. You're all wonderful people. Take care.